The phenomenon of social contagion is very important to a lot of problems that we're facing in the world today. It's relevant to the spread of misinformation. It's relevant to the spread of political extremism. It's relevant to the adoption of useful innovations, new technological innovations, for example, within firms or within populations. It's relevant to health practices, as we've been showing in our work. So many of the important problems that we face in the world today have, at least as part of their cause, social contagion.
If we use the power of social networks, which is the natural capacity that we have to influence people around us and in turn receive influence from them, but not only from those directly connected, but those that are connected at 2 or 3 degrees of separation, then we might be able to leverage the ways in which we do public health interventions.
So the basic idea is that you can identify a population of human beings, and each of those people is then connected to other people, and those people are in turn connected to still other people. And this gives rise to a kind of vast, intricate pattern of social interactions, namely a social network. And then you can use mathematical insights to identify people within the network who are structurally influential. People who, if you persuade them to adopt a new practice, like to breastfeed their children, for example, or to deliver their babies at a hospital rather than at home, or to vaccinate themselves, or to better treat diarrhea or respiratory diseases, or to wash their hands, or any number of other beneficial practices, if you could persuade those crucial individuals within a population, they would make everyone in the population copy them. For this project, we decided we needed a larger population, actually more isolated even than the original population in Honduras. And so we started working in the Copan region on the western part of the country. Methodologically, we wanted the villages to be isolated from each other because we wanted most of the social connections to be within the villages rather than between the villages. And we wanted the populations to have a natural boundary. So we mapped all the social connections that we possibly could within each village to really have a deep understanding of the network structure of each village. And so this area where we were working offered these methodologic advantages from the point of view of the networks, but it was also an important applied area because this region is very representative of the kinds of challenging environments people engaged in public health and development economics initiatives around the world practice. So this is a very representative area from that point of view.
We created something called the Trellis software, which is a social network appraisal software that utilizes pictures to allow people to identify their social networks.
At the time, there wasn't any other software out there that could meet our specific needs, so we needed something that worked offline in these rural villages where there's no internet, and also could do photographic network mapping. Trellis is interesting because it enables this research in rural communities. So the ability to go out into these locations and collect this kind of data is very, very useful for our lab and other labs like ours.
This is still probably the largest RCT involving a social network intervention ever done in history, and it involved 176 villages in Department of Copan, and that amounted to about 24,000 individuals. So the scale is really pretty massive in terms of this type of research project.
The first step in the field, in this bringing the lab to the field approach, was going to everybody's house. Literally, we went to visit every single household to interview all the members of the household and to be able to discern who were their friends, their families, the people that they don't get along with, their partners, basically their entire social network.
Con su trabajo,
quizá sea mejor usarla durante la noche, pero si a veces se pierden también no es ideal, pero...
Vamos a las comunidades, visitamos los hogares y visitamos cada una de las personas que están dentro de nuestra base de datos, en nuestro listado, para poder hablar con ellos. ¿Verdad? Entonces, toda la información que se recopila por medio de una tableta, por medio de una encuesta.
Bueno, con este tipo de investigaciones, pues Estamos generando mucho conocimiento, estamos generando datos, estamos aportando a la ciencia y esperamos pues que con los resultados pues puedan venir o puedan haber intervenciones en el futuro que ayuden no solo a estas comunidades, sino que a comunidades también similares, con características similares a estas.
It took a very long time to answer this question. It began as an idea in 2013 where we sketched out a sketch on a whiteboard at Yale in the lab. And the question was, could we shift the adoption curve to the left? In other words, if on the x-axis is time and on the y-axis is fraction of people adopting, could you have this sort of S-shaped diffusion of innovation curve that many people know about, where initially there are very few people that adopt, and then all of a sudden you have this sort of epidemic growth phase of adoption, and then it plateaus? Could we shift that curve to the left using these techniques? Actually, the way we sketched it out, what varied on the x-axis was the fraction of people targeted, from 0 to 100%, the fraction of the people in the village that were given the intervention. And then on the y-axis was the fraction of people that adopted the intervention. And the question was, could we invent a technique that made it possible so that if you shrewdly picked, let's say, 20% of the people in the village, it would be as effective as if you had given it to 100% of the people in the village. So we raised money from multiple sources to do this mammoth randomized controlled trial in these 176 isolated villages. So the trial started in approximately 2015. We had to map all the networks of all of these people. Then we had to randomly assign them to get this 22-month educational intervention, which was a very standard sort of development, economic, public health intervention. And then once a month, visiting health workers would go to these people's homes and teach them about neonatal care and diarrheal illness and so on. So that took 2 years, and then we had to then reevaluate the outcomes at that point. And then it took 2 or 3 years to analyze the data, and then another year to get it through peer review. And finally, in 2024, the results of the randomized control trial were published, and we were able to show that this could be done. We were able to show that we could exploit social contagion for good, that we were able to identify, using these mathematical ideas, structurally influential individuals within these villages, such that if you persuade them to change their behavior, the whole village will copy them. It's sort of a mathematical property of human social networks that your friends have more friends than you do. So if you go into a village, pick 10% of the people at random, ask them who their friends are, and pick one of those friends at random, and deliver the intervention to that subgroup of people, that 10% of the people, that group of 10% of the people identified using the friendship paradox, actually you have a much bigger impact, because those people are more structurally influential. They cause bigger cascade effects. They induce more social contagion. For these tools to actually be used to make the world better, we need to invent techniques for identifying structurally influential people within human populations without having to map the whole network. If every time you wanted to do this, you had to go through the headache and the expense, and it might not even be possible to map the networks, nobody would ever use this.
This knowledge now can potentially inform decisions, and those decisions will improve the human flourishing of people in other sites of the world that also live in similar conditions. So in principle, what we created is a tool that can be adapted to other settings different than Honduras, while also intervening our population of study and working with them to be able to serve the global majority of the world that hopefully will change the way in which we approach public health interventions moving forward.
I think it's important to understand, at least in my point of view, that fundamental discovery-based science is a magnificent and beautiful thing in and of itself. Understanding the world and satisfying our curiosity about how things work is worth it in and of itself. And what we're seeking to do in my lab is really understand the structure and function of human social interactions. Why do we make networks? Why do they have the properties that they do? How do they affect our lives? These are deep and interesting questions as far as I'm concerned. But in addition, there's another reason here, which is that quite beyond the mere satisfaction in understanding this really interesting natural phenomenon, which is social networks. And that reason is that we can use this knowledge to intervene in the world to make it better. So it's my hope that these methods will actually make it possible to be much more efficient and effective across a range of public policy challenges.